Good morning. My name is Manoj Kumar, Assistant Professor, Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Today, in this video lecture, we will learn about the binary tree in data structure. This is the content that I will discuss in this lecture. At first, we will discuss about the basic introduction of binary tree. Then, what are different tree traversal methods. After that, we will see some problem based on the tree traversal methods in binary tree. And after completing that, we will learn about the binary search tree. And after that, we will discuss about the insertion and deletion operation in binary search tree with an example. So let's start with the introduction of binary tree. Binary tree is a non-linear data structure. It is a hierarchical data structure in which data is organized in form of nodes. And in case of binary tree, every node can have either 0 children, 1 children, or at most 2 children. It means number of children, maximum number of children of a particular node will be 2. Okay, this is an example of the binary tree. In this tree, A is the root of the tree, B and C is the child of the node A, and this is the left subtree and this is the right subtree. In this tree, the maximum number of child node is 2 for a particular node. A and B for node A, V and C is the child, B, D and E is the child, and for C, node F and G is the child, and for D, node H and I is the child. Okay, so this is a binary tree. So in every binary tree has a left and right reference along with the data element. So this is a left pointer to the left child, and this is a right pointer is in context to node which contain the address of right child of node A, C. Okay. Node at the top of the hierarchy is known as the root of the tree. There will be only one root node. In this case, A is the root of the tree. And this is the basic example of the binary tree. Now, a different tree traversal method. It means whenever we visit a tree, then what may be the possible sequences. So, in order to visit the every element or every node of a tree, there are 3 basic methods. First one is the pre-order traversal, in-order traversal, and post-order traversal. We will see in the next slide one by one. So first is the pre-order traversal. So whenever we have to traverse a tree using pre-order method, then there are some certain rules. These rules are discussed in 3 points. At first, we will visit the root node. So in order to traverse a given tree in pre-order manner, first we visit the root node. It means first we display the data value of the root node. After that, visit the left subtree using pre-order. We will visit the left subtree of that particular node using pre-order. It means again we will follow the rule left, root, left and right, and after that we will visit the right subtree. So for pre-order, there are rule. At first we will visit the root, after that we will visit the left subtree, and then we will visit the right subtree using pre-order. We will see the example later. So in order to traverse a tree using pre-order manner, first we will visit the root. After that, we will visit the left subtree using pre-order. It means we will visit the complete left subtree again using this rule. And when the left subtree will be visited completed, after that we will visit the right subtree of a particular node. Again, to visit the right subtree, we have to follow this particular route. Okay. Next is the in-order traversal. In-order traversal means in using in-order traversal method, at first we will visit the left subtree using in-order. For this, the basic rule is left, root and right. So first we will visit the left subtree completely of a particular node. After that, we will visit that node or root. And once the root is visited, after that we will visit the right subtree again using the in-order. It means again following this rule. Third method is the post-order traversal. So whenever we have to traverse a given tree using post-order method, then we have to follow the rule left, right and root. So it means at first we visit the left subtree completely using post order. It means by following this rule, we will visit the left subtree. Once the left subtree has been visited, after that we will visit the right subtree. Again, to visit the right subtree, we will have to keep in mind these rule. Okay, so once the left subtree and right subtree both has been visited, after that in the last we will visit the root of the node. So let us discuss example of each. So this is the given tree. In this tree, A is the root node, B and C is the child of A, and B has the child D, and C has the child E, F, and E has the child G, H and I are the child of F. So whenever we will visit this tree in pre-order sequence, so in pre-order sequence at first root will be visited. So A. Again we will visit, this is the left subtree of A. And this is the right subtree of A. And this is our root. So at first for pre-order rule is root, left and right. So using this rule, at first A will be visited, then we will again visit this root, left, right. So B and D. After that we will visit the right subtree, so C, E and G. After that F, H and I. So this is the pre-order sequence, traversal sequence for this given tree. Now we have to traverse the tree in post order. So in post order, the rule is left, right and root. So in this case, at first this is the left subtree. So we will visit the left subtree using this rule. So in the left subtree, at first we will visit D. There is no element in the right, so it will not be visited. After that we will come to root. Root of the left subtree is B. So this is B. Left subtree has been visited completely. Now we will visit the right subtree again following this rule. So in right subtree, this is the again left and this is again right. So we will use this rule to visit this. So in this case, there is no left, there is right. So again G will visited. After that E will visited. Left is visited completely. Now we will visit this. So left, right and root. So H, I, F. H, I, F. Now left subtree has been visited completely, after this we will visit the C. Right subtree has been visited completely. After that we will visit A. So this is the D, B, G, E, H, I, F, C, A. This will be the in or post order sequence of the given tree. Now next come to the in order. To traverse a tree using in order, we have to follow the rule left, root and right. So in this case, this is the left subtree. Again we will visit this left subtree using this rule. So left will be D. After that we will come to root. Root is B and there is no in the right child of B. So we will come to root A. So the left subtree is visited completely. After that we will complete the root. Now come to the right subtree. In case of right subtree, again we will visit this complete right subtree by following this rule left, root, right. So right subtree left will be this and left there is no in left of left child of E. So E will be visited. After that E will be visited, G will be visited, left subtree is visited, then root, C is visited. Now come to this left, root, right. So H, F, I. Okay. This is the root A. Let us see another example of tree traversing method. So this is the given tree. Again we have to find the pre-order, in order and post order sequence. So pre-order left, root, left, right. So at first P will be visited, then F, B, F, B. After that H, G, H, G. So left, this is the left subtree. This is visited completely. This is visited and this is the right subtree of the node P. So now we will visit the right subtree again for pre-order root, left, right. So S, after G, S, then R. Again for this subtree we will again follow these rule left, root, right. So by T, W and Z. So this will be the pre-order sequence for the given tree. Now come to the post order. In case of post order, what is the rule? Left, right and root. So at first we will visit the left subtree using this rule. So left B, again right G H, V G H. Now come to this right subtree. Right subtree mein again we will visit the left, right and root. Left, right and again this will F will be visited here, left, right and root. So at first R, again left subtree will be visited, the child of S is R. Next we will visit W, then T, then Z, then Y. Okay, after that S will be visited and in the last root will be visited P. Now come to the in order. To traverse the in order, we follow the rule left, root and right. Okay, so left in order traversal of the given tree will be, at first we will visit the left subtree. So left, root and right. So V, F, then G, H. This is the sequence or in order sequence of the left subtree. Now come to the root. Root is P. After that visit the left, right subtree following the these rule left, root, right. So R, after that S, root, then come to this left, there is no left of T, after that T, W, T, W, then Y, then Z. So this will be the in order, pre-order and post-order sequences of the given tree. Now in some problem based on the tree traversal method are asked in this manner. Basically in case of AKTU examination, two sequences will be given and we have to construct the tree from the given sequences. For example, this is the problem 1. In this problem we have given the in order sequence and pre-order sequence for a particular tree. Now we have to make the binary tree. Okay, so in this type of problem, two sequences will be given. Either it may be the in order sequence and pre-order sequence, or it may be the post-order sequence and in order sequence, and we have to construct the tree. So such type of questions are asked in the university examination. So how we will construct the tree from the given sequence? Okay, so at first in this to solve such type of problem, first we will find the root of the tree. It means what will be the root of the tree. So in order to find the root of the tree, we will see the pre-order sequence or post-order which is given in the question. So in this question the pre-order sequence is given and we know that in case of pre-order at first the root node will be visited. So here first node is A. It means according to the root of rule of pre-order. What is the root of rule of pre-order? Root, left and right. So it means A will be the tree. A will be the root of the tree to which we have to construct. So first we will make the root of the tree. Now after this, in the second step, we will see that how many elements will be in the left subtree and the elements which will be in the right subtree. So in order to find the elements which will belong to the left subtree of this node root node A, we will see the in order sequence. So in order sequence, all the elements which are in the on the left side, they will be in the left subtree, and all the elements which belong to the right side of root node, they will be in the right subtree. Okay, so B and C, node B and C will belong to in the left subtree of A, and node E, D, G, H, F, I, J, that will belong to the right subtree of A. So at first we will construct the left subtree of root node. So in order to construct left subtree, again we will see the in order sequence and pre-order sequence. So in order sequence is B and C and pre-order sequence is B, C. It means since in the pre-order sequence of BC, B become first, B traverse first, it means B will be the root of the left subtree. Okay, again this is the in order sequence BC and this is the pre-order sequence BC. So C will be the right child of B. So when we will traverse it, let us traverse, there is no left child. So in order sequence for this will be left, root, right. So there is no left, it means B, then we will visit the root B, V and C. Again see the pre-order sequence, root, left, right, there is no left, so V and C. So pre-order sequence and in-order sequence are same. So this will be the structure of left subtree. So we have constructed the root and we have also constructed the left subtree. Now in the third step, we will construct the right subtree of the root node. In order to construct the right subtree of the root node, again we will find the root of right subtree and we will find the elements which belong to the right subtree and which belong to the left subtree. So let us see the pre-order sequence. In pre-order sequence, D is bitted first. It means D will be the root of the right subtree. So here D is the root of the right subtree. Now see the in-order sequence. The node E and G are in the left side of D and these node H, F, I, J are the right side. These belong to the left side, these belong to the right side. It means E and G will belong to the left subtree of D and H, F, I, J belong to the right subtree of E. Again we have to construct first the left subtree of D. So in-order sequence is easy and pre-order sequence is easy. Again here, so E will be the root, okay, and G will be the left child, okay. So in order sequence, this will become to E and Z. So A, B, C, A, B, C, A. After that, we will traverse the in order sequence E, G, D, E, G, and in order sequence root left. What is the in order sequence? Left, root, and right. So left, G, E, and so here this will belongs to this EG. Sorry. So G will be the right child of this. So E and Z, this will be the sequence, and again here in case of pre-order E and G, this will be the sequence. So here G belong to the left child. Okay. Now we will construct the right subtree of node D. So in case of right subtree of node D, at first we will see the pre-order sequence. So F is the first node. So it will be the root of the right subtree of D. Now again we will see in case of in-order sequence, there is only one node in the left of F. It means node H will be the left subtree of node F. Okay, and element I and J, that will belong to the right subtree. So here the in-order sequence is Ij and post-order sequence is Ij. So let us discuss the in-order traversal of this. So left, root, and right. There is no left. So in this case, I and J will be the sequence. Again, pre-order sequence I and J. So this will be the complete binary. This will be the final binary tree for the given sequence. In this type of problem, we have a facility that whatever tree will be constructed, we can verify that whether our tree is correct or not, because this is the final tree. Now if we traverse the in-order sequence and pre-order sequence for this tree, and that sequence will match to the given sequence in the question, it means our tree is constructed right. Okay, so here you can match the B, C, A in order. After that E, G, D, then H, F, then I, J. This will be the in-order sequence. And again for pre-order A, B, C, D, E, G, F, H, I, J. So this is the right tree that is constructed for the given sequence. This is another problem. Here we have given the in-order sequence and post-order sequence, and again we have to construct the tree. So in case of post-order, the rule is left, right, and root. Okay, so here root will be of tree will be A. So at first in step 1, again we will find the root of the tree, and then we will find the elements which belong to in the left subtree and which belong to the right subtree. So here root will be A. Now see from the in-order sequence, these elements will belong to the left subtree and these elements will belong to the right subtree. Again we will construct the left subtree first. So from the left subtree, since in this sequence B is in the last in case of post-order sequence, so B will be the root. Okay, and in-order sequence is ID, so ID. Again post-order sequence is ID because there is no right of child of D, so this will be the left subtree. Okay, now we will construct the right subtree. In case of right subtree, since E is given in the last in case of post-order sequence, so E will be the root of the right subtree. Again, these element which are in the left side, C and G, this belong to the left subtree of node A, and element H and F belong to the right subtree of A. Okay, so this will be the arrangement. In order sequence is C, Z, and for right subtree H, F. So let us verify whether this tree is right or not. So traverse it in order manner. So in order manner, at first what is left, root, and right. So here there is no left of B. So B will be written first, B, then I, D, A. So V, I, D, A. Okay. After that, beat here C, Z, E, H, F. So this is correct. Now again traverse in post order manner. Post order manner, first we will traverse the left subtree, then right subtree, and then root. So here there is no in the left. So we start from the right. I, D, B. I, D, B. Then visit the right subtree. There is no in left. Z, C, H, F, E, and in the last A. So this is the correct tree for the given sequences. Now let us discuss about the binary search tree. What is binary search tree? Actually, binary search tree is a type of binary tree which contains some property. In case of binary subtree, every node of the tree has a unique key value, and in the left subtree of that particular node, all the nodes which belong to the left subtree, they will contain the less value. Okay, and all the node that belong to the right subtree of a particular node, they will contain the greater value. Okay, so every element has a key, and no two elements have the same key. The key in the left subtree are smaller than the key in the root. Key in the right subtree will be the larger than the root, and left and right subtree are also the binary search tree. Okay, this is the example of binary search tree. Here root is 16. So all the node which belong to the left subtree of the 16, they will contain the less value than 16. Okay, so 12, left side, in the left there is 11, or in the right 14 and 13. Okay, so in the right subtree of a particular node, value will be greater than that node, and in the left subtree value will be less. Okay, so 20 comes to the right side because 20 is greater than 16. Again, since 19 is greater than 16, so 19 will be in the left subtree of 16. But since 19 is less than 20, so it belongs to the left subtree of root node 20. Okay, so binary search tree is a binary tree in which every node has a unique key, and all the value which is lesser than for a particular node, they will belong to the left subtree of that node, and all the key which is greater than that particular node value, that belong to the right subtree of that particular node. Let us perform the insertion operation in binary search tree. Again, whenever we have to insert a new node in binary search tree, at first we have to compare the key value of that node with the root. If it is greater than root, then that new key will be inserted in the right subtree, or if it is less than root, then it will inserted in the left subtree. Let us see an example. So this is a binary search tree. In this binary tree, we have to insert the new node 65. Okay, so at first we compare the 65 here. 65 is greater than 45. It means 65 will be inserted in the right subtree. Now we come here. Here we compare the 65 with 79. Since 65, it means the new node to be inserted is less than the 79. So it will be inserted in the left subtree of 79. Now again, we will compare here 65 and 55. Since 65 is greater than the 55, so 65 will be in the right subtree of the 55. So after inserting, this will be the final binary search tree. So this tree is given, and when we have to insert a new node with key value 65, then it will be inserted at this position. So this will be the tree after insertion. Next, deletion in binary search tree. So whenever we have to delete a particular node from binary search tree, then there are three cases. First case may be the node to which we want to delete that has no child. Second, node has node to be deleted has one child, and third, node has to be deleted has two children. So there are different algorithms. At first, this is the case one, when node to be deleted has only one child. In that case, we can simply delete that node using free function. Suppose we have to this is the given binary search tree. Now we have to delete this particular node. since the node to be deleted is 90 and this node doesn't have any child, so we will simply remove it from the binary search tree. So this will be the tree after deleting the 90 from the given tree. Case 2. Whenever we have to delete a particular node which has one children. For example, here we have to delete the 79. Since 79 has one child, that is the 55. Okay, so whenever we have to delete a node that has one child, then what we will do? We will make a connection between the parent between the parent of the node to be deleted and its child, and after that we will delete it. Okay, so we will, it means or you can say that we will swap its child and its value, then 79 become the leaf node, we will delete it, and 55 will become the child of 45. So after deleting this node, the binary search tree will become this. It means 55 will be the child of 45. Case 3. Whenever we have to delete a node which has two children. So this is an important case. In this case, there are two methods. At first, we will use the pre-order in-order successor. And in second method, we will use the pre-order successor. Pre-order successor and in-order predecessor and in-order successor. So suppose this is the given tree and we have to delete the node 45. So node 45 has two children. One is 15 and another is 79. So using method 1. In this method, at first we will swap the node to be deleted with its in-order predecessor. So we will find the in-order sequence of this tree. So in-order sequence will be 10, 15, then 20, then 45, then 55, then 79. So in order predecessor of 45 is 20. So we will swap that value of 45 with 20. So 20 will become so after we will replace the in order. This is the case of in order successor. So in order successor of 45 is 55. So we will swap 45 and 55. So 55 is here. So 55 is here, and 45 become the leaf node. Now we will delete simply it. So after deleting 45 using in order successor method, this will be the binary search tree. Okay, but what if we have to use the in order predecessor? So what we will do in case of 45 using in order predecessor, 45 will be swapped with 20 because 20 is the in order predecessor. So in that case, in case of in order predecessor, what will be the tree here? 20, and this will be 15, and this will be 10, and here this will be 79, and this will be 55. Okay, so if we use this method 40 in order predecessor, so we will swap the 45 node to be deleted with it in order predecessor, and that is the 20. So we will swap the 45 and 20. So 45 will become the leaf node and we will simply delete it, and this will be the BST. In case of second method, in order successor, this is the tree. Successor of in order successor of 45 is 55. So we will swap 45 with 55. Okay, and 45 become the root leaf node. We will delete it, and this will be the BST. Okay, thank you.